In this video, we're going to talk about rotations over a coordinate plane. So our investigation starts with tracing the rectangle given over here on your patty paper. So we need to include both of the axes. I'm going to explain why in just a second. So you should have a plain piece of patty paper that you're going to lay on top and trace. You can pause the video if you need to take some time to trace it, but this is what your shape should look like once you have your two axes on it. So I'm just going to line it up just like this. And then looking at this directions, it says label the points of the rectangle, your patty paper. Okay, I did M-A-T-H. And I'm going to turn the patty paper one turn to the right. So in order to do this, I'm going to show that my point of rotation is going to be my origin point. So I can put my finger on the origin point. That way I can kind of rotate a little bit easier, okay? So if I'm moving it to the right, that way I can show that my rectangle is going to go into this quadrant 4. So if this is quadrant 1, I'm going to go down to quadrant 4. When I turn that, I'm going to line my x-axis and my y-axis back up. And I'm able to see that my rectangle would land kind of sideways down in this quadrant 4. So I'm going to carefully peel up my paper and I'm going to plot my points of where they should be. So when I have my 4 points, I can make sure that I have the correct things, and I can know that my M prime would be down here, A prime, and then T prime and H prime. So by labeling those with those little primes, that tells me that this was my pre-image. This is the image that I started with. And then this was my image or my ending picture. So the question over on the left, it says, what changed between the pre-image and the image? So looking at this, we can easily say that the orientation was changed because this rectangle was sitting upright, and then when I turned it or rotated it, it fell over on its side. So I can say that the orientation is different because the shape turned. And then we can also say that the similarities would be that they have the same shape, meaning that it's still a rectangle, and the size stayed the same as well. It didn't get bigger or smaller. So saying something about how the orientation, if it's turned, is different, but it is the same shape and the same size. So when we talk about rotations, there's going to be several rotations that we're going to practice, and this graphic will kind of help you figure out which direction and what to do. So the question that I asked on this paper is, if you cut a circle into 4 pieces, how many degrees are in each piece? So on this coordinate grid, I've added a circle, and we know that the entire circle is 360 degrees. And if we split that circle into the 4 sections or the 4 quadrants, 360 divided by 4 would be 90. So a lot of you recognize that this is going to be just a 90-degree angle. So each of these quadrants are 90 degrees. So if I'm looking to rotate something 90 degrees, that would just be one turn. So like what we did up on the top, we moved from one line to the next line. So that would be one turn. If I want 180 degrees, that means that I would need 2 of these, because I would have 90 and then another 90 would be 180. So that means I would have to turn it 2 times. My 270, that would show a 90, another turn to get the 180, and then another turn to get that 270. So this would be 3 turns. And then of course, if I truly say rotate something 360 degrees, then that just means that I would have to rotate it 4 times. But that is completely pointless, because if I did a 360 degree turn, then that is going to be back to my original shape. And the entire purpose of rotating something is to get a different image. So when we look at rotations, they're going to tell you how many degrees to turn it, and then also which direction, if we're going to turn it to the right or if we're going to turn the shape to the left. So if we think of a clock, this is the direction that a clock makes, so this is called clockwise. So if we're going to go to the right, then that would be clockwise, and if we're going to go to the left, then that would be counterclockwise. So by knowing which direction that we're going, either left or right, clockwise or counterclockwise, and then also the degrees, we are able to rotate some shapes pretty easily. So flip your paper over. We have an example with this triangle. So take another sheet of patty paper or use the original one that you had, it doesn't matter, and make sure that you are writing down or tracing the shape and the 2 axes. So you can pause the video if you need to kind of trace what I have on my patty paper already. So over here on the box, it says to rotate the triangle ABC 90 degrees clockwise. So clockwise tells me that I'm going to be going to the right, turning it to the right. So I would be rotating it like this, towards the way that a clock would be rotating, okay? When I rotate it the clockwise motion, I can see that my triangle is going to be orientated different, but all of the same lengths are still being used. So when I'm looking at this, I can see that my points would land at different spots. So I'm going to take a second and put my points where they need to go. This is kind of the tricky part. All right, so once I have my 3 points kind of lined up with my image, I can go and take this off and connect the dots. And whenever I have an image like this, I want to make sure that I am going back and making sure that I have all of my points lined up. So this is my point B, so that is now B prime with a little apostrophe. Then I have A prime on this side, and I will have C prime here. So by doing this, this is going to help me when I have to fill out my image coordinates. So I know that this is my image because that's my final picture. And I know that I can go ahead and write my coordinates. So A prime is going to be at -6, -4, or sorry, +4. B prime is going to be at -3, +7. And C prime is going to be at -4, +2. So by doing that rotation with the patty paper, I'm easily able to see where my new points are going to be. And I can also start to see the relationship between my coordinates. I can see that I'm still using the same digits, a 7 and a 3 on the B and so on and so forth, but the order is kind of different. And we'll talk about that in a second. All right, so let's talk about this next box. It says rotate triangle ABC 270 degrees counterclockwise. So that's against the clock. So if I take my original paper again, this time, instead of going to the right like the clock motion, I'm going to be going to the left or counterclockwise against the clock motion. So again, I'm going to hold my patty paper in the middle and I'm going to trace or work backwards. So if this is one turn, that's 90 degrees. If I do another turn, it's going to be 180 degrees. And then I have to do a third turn, which would be my 270. So if I turn it a third time, I can see that a 270 degrees counterclockwise is going to get me to the same spot that a 90 degrees clockwise is going to be. So it doesn't really matter which direction you go. You will have to do some more turns on a certain, either the clockwise or the counterclockwise. So what do we notice when we do the 270 counterclockwise? This gives us the same image as a 90 degree clockwise rotation. So this is the same as a 90 degrees clockwise rotation. So it doesn't really matter which way I go, I would still end up being at the same spot, whether I do 90 degrees clockwise or 270 degrees counterclockwise. And I know that's kind of weird, but the way that it works is if you, either way you do it, you're going to end up with the same rule. Okay, so I'm going to write the rules down. We'll explain these a little bit. The rules are kind of tricky for rotations, but we'll keep practicing them in class. All right, so the rule for a 90 degree clockwise or a 270 degrees counterclockwise, remember these two things are the same thing, we just proved it up on the top of our paper. We are going to take the rule y, comma, negative x. I know that's weird, and we're going to explain it in a second. The next rule for 180 degrees clockwise and 180 degrees counterclockwise are the same because no matter what, you're going to turn it 2 times. So this is going to be the opposite of x, opposite of y. And then the last one is going to be the opposite of y, x. And I know that was weird, but we're going to practice. All right, so we're going to try this now. So this is the image, the pre-image point that we're going to rotate. And we're going to rotate it 90 degrees clockwise. So if I look at my table, I have a 90 degrees clockwise. I'm going to use this rule. So I'm going to actually write that right here. So what this rule tells me that I'm going to leave my y value the same. So my y value is 4, and now that is my first number. My x value changes it to its opposite. So I have a positive 5, so now I'm going to have a negative 5, and that's going to go behind this number. So my new rotation point is right here. Now again, I could just honestly plot this point on a grid and just use a patty paper and rotate it myself, but sometimes rules are easier to understand if you are that type of person. So if I have a negative 3, 1, and I'm rotating it 180 degrees, my 180 degree rule is negative x, negative y, or the opposite of those. So the opposite of negative 3 would be positive 3. The opposite of positive 1 would be negative 1. That one's pretty easy. It just kind of goes to the opposite because it would be the opposite quadrant. And then we have a 90 degrees counterclockwise. 90 degrees counterclockwise would be right here in my table of rules, and it uses the rule negative y, x. So I'm going to take my y value. My y value right now is 8, and I'm going to take the opposite of, negative 8. I'm going to take the opposite of negative 8, and that is going to be positive 8 now. My x value is negative 2, so I'm going to put negative 2 behind there. So now you should have a practice page, and good luck.